Hello guys, today in this video tutorial I will be introducing a new sensor that is ADC081C. Now to gain more knowledge about this sensor, let's visit the website that is controleverything.com, and here we have to search on for this sensor as you can see on my screen. And here we go. As you can see, it's a 8-bit 1-channel high-speed ADC, analog to digital converter, and as you can see these are some of its more prominent features. As also, you can purchase this sensor from this website, from here. Now in this video, I will be interfacing the ADC analog to digital converter 081C, as you can see, with a particle photon, and for that I require a particle code. To get that code, let's go to resource tab, and here comes the particle code sample. Now you can download the particle code sample as a zip file from here, and also you can have the code from GitHub repository that is Control Everything community. Now we require to make some connections of the hardware for this video tutorial, and let's see what we got there. Well, coming to the hardware connection setup part, the first thing we require, which you are able to see on my screen, is a particle photon. Now this here is an I2C Shield. It's available and can be purchased from the website controleverything.com, and the reason we are using this shield is to make connections easier with other I2C devices. So for that, what we require is to gently place this particle photon over the I2C shield and make a connection just like that. Now to power up this particle photon, what do we require is a micro USB cable, which you can see on my screen, and gently insert it over this power jack. Now next we require our sensor, that is ADC081C, and this here is our connecting cable. Now to make a connection among the sensor and the cable, we make sure that the ground terminal of the sensor should be connected to the brown wire of the cable, and similarly this rule has to be applied to the I2C shield. So as we are done with the connections part, now our requirement is of the explanation of the code. So let's have it. Well, let's have a look over the interfacing section now, and for that we have to log into github.com, and here we have to search for the repository that is Control Everything community, and then we have to log into our sensor, that is ADC081C, and here comes the particle code. Before moving to the code, let's have a look over the instructions we need to follow up, and it says that we have to log into a particle photon and set up the device, and the instructions are on this link. Let's open up this link. As you can see, these are some of the instructions and the commands we need to follow for the successful connection and setup. After that, we are going to download the code, and we are going to copy the code on the online ID, and build.particle is the online ID where we need to create a new file. We will paste the entire code and then save it. And after that, the last step is to verify and flash the code on the particle photon, and the code output will be displayed in the form of logs at the dashboard, and dashboard.particle is the platform where we will have the relevant output onto the screen. So after these instructions, we need to get back to the particle code, which is a .in extension file. Now click over here, and as you can see in the code, we have included application.h and spark wiring I2C.h header files, and we have defined the address of the sensor, that is 0x50. We have initialized an integer which is raw ADC equal to 0, and in the void setter function we have set variable, as you can see here it is, and we have initialized I2C communication as master along with serial communication with the baud rate equal to 9600. Now in the writing section part, we are going to select the configuration register having address 0x02, and we are going to send or write the command that is for automatic conversion mode enabled, that is 0x20. After that, in the void loop function, we are going to select the data register 0x00 for the reading section part, and here comes the request and the reading of 2 bytes of data, which is raw ADC MSB along with raw ADC LSB. After that, we are going to convert the data into 8 bits, which is according to the guidelines and the formulas provided for the data sheet of ADC081C. At the very end of our output code, as you can see, we have to display this relevant output onto the dashboard, which is the raw value of the source. So this is how the code looks like of the particle. Now let's have a look over how it works. Now coming to the working environment section, the step is to copy this entire code of the particle as you can see on my screen, and we have to open up the build terminal, that's the online ID for particle Photon, and here we have to create a new file, that is ADC081C, and we have to paste the entire code here. We have just copied, and then to save it. After that we have to verify and compile the code, and it's done successfully and it's great work. Then we have to check for the magenta flash, and we have to check it because it will confirm that the code is good to go and we can have our output data onto the screen. So just now we have the magenta flash onto the screen, and as you can notice we have the successful notification here. Now the next step is to look over for the output, and for that we have to open up the dashboard user logs link, and let's open it up and let's see what we got here. As you can see, we have the raw value of the input source. It's the digital value of the analog input. It's 0, exactly 0, which means that there is nothing connected onto the terminals of the sensor, but instead when I try to connect it with a AA battery of 1.5 volt, we have the raw value of the source, which you can see is almost constant right now. It's near about 49. It's coming constant because there is a battery connected. It's checking the voltage among the two terminals, plus and negative. So this is how the sensor works. Now the next step is to look over the benefits, features and the applications of this particular sensor. The ADC081C is a low power monolithic 8-bit analog to digital converter that operates from a plus 2.7 to 5.5 volt supply. The converter is based on a successive approximation resistor architecture with an internal track and hold circuit that can handle input frequencies up to 11 MHz. Due to these variables and a lot of features, a lot of applications are dependent on this sensor, which includes system monitoring, peak detection, portable instruments, medical instruments and test equipment. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site you can download the code as zip file. Also you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor or video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.